So in this video, we're going to talk about one-sided limits, something that I have briefly mentioned in the past, but not really pointed it out very well. And so a one-sided limit, if we think about a two-sided limit or just the overall limit that we've been studying, we've always talked about needing to come in from both sides, the left and the right, and getting the same answer. Well, for one-sided limits, that really just narrows it down to saying, okay, we want to come in from one direction. So the notation that we'll use for this will be the limit as x approaches c with this superscript plus, or a limit as x approaches c with the superscript minus. The superscript plus means from the right. So a right-handed limit, a right-sided limit. The minus would be from the left. So the limit from the right and the limit from the left. So if we go now back, and I'll put up an example that we've seen here in the past of, I believe it was absolute x over x, as well as now the limit from the left of absolute x over x. This is one that we talked about a couple videos ago. This graph, if you remember, was 1 when everything is positive and -1 when everything is negative. So for our first example, when we approach 0 from the right, all we care about is the y value when we approach only from the right. So here, as I come in to 0 from the right, you can see I'd be up here at 1. So this limit would equal 1. Similarly now, if I approach 0 from the left, approaching 0 from the left now would bring me down to my -1. So a couple sections ago, when the question was, what is the limit as x approaches 0 of this function, we said the answer was does not exist, D and E. And that's because the answers were different. But now we've broken it down into two separate questions. From the right, we're at 1. From the left, we're at -1. So a pretty intuitive idea when you just get past the notation. Okay? So the next thing that I'm going to mention is a really important theorem, one that should hopefully make sense now that we've had this discussion. The limit as x approaches c of f of x equals L, IFF, if and only if. I'll explain that here in a second. The limit as x approaches c from the right equals L, which also equals the limit as x approaches c from the left. So here's our theorem here. So what it says is the overall limit will only equal L if the right hand limit and the left hand limit both also equal L. It's an if and only if statement, which means it goes both ways. If this is true, then this is true. But it also says if this is true, then this is true. And so again, it's kind of now summarizing some of the smaller informal discussions that we've had in the past few sections. Okay, now what I want you guys to do is actually go to page 70 in your text. So page 70 in your text, and I want you to pause the video and I want you to work example 2. So on a separate piece of paper, work example 2. You should be armed with enough information at this point to answer these questions. They're true and false. I'm going to go ahead and pause the video, give you an opportunity to work these problems, or work this problem. There's several parts to it. And then when you're finished, go ahead and restart the video, and I will give you guys the answers to these. All right, so those are the answers to the problem on number 70, or page 70, number 2. Hopefully you got those. If not, you can circle back and review them. And if you're still not quite seeing why the answer is what it is, please feel free to contact me or bring it up on our next call and we can talk about that. But again, what we're doing here really isn't all that different from what you've been doing in the past. It's just now a matter of understanding you're only coming in from one direction versus the other. Okay, so now we'll take a look at a limit that we're not really going to be able to graph fully, but It's still a limit in the same way that it's always been, where we take our number. You can certainly plug the 1 in. You can see you're not going to get anywhere by doing that. So we're going to need to manipulate. Now, I will go ahead and take advantage of our limit laws in this case. If anything, just to make it a little bit clearer as I talk through it, I know that one of our limit laws says that we can do this, where I've split this apart now as a product. And I'd like to focus in on this guy right here. This is a similar function to what we've seen in the past, where the outcome is either going to be a positive one or a negative one. So I'd encourage you to take just a few minutes and graph that if you need to. It would turn into that piecewise function again. But is it going to turn into the positive one, or is it going to turn into the negative one? Well, if you think about it, we're approaching 1 from the left, which means we're looking at numbers less than 1. So something like 0.9, 0.8, something like that. Well, if I take any number and plug it in down here, it's always going to be positive, right? So any number I plug in there, it's always going to be positive. But in the numerator, when I take a number like 0.9 and I plug it in there, 0.9 minus 1 is going to give us a negative number. So a negative divided by a positive will always give us a negative number. So that limit actually ends up being -1. So as I come back over here now, essentially now I'm putting these back together. We're going to have a negative root 2x right there. And so when I take my 1 now and I plug it in, it's going to give me the answer of negative root 2. And so this would be my final answer here to the limit, having gotten there by needing to understand which direction that I was actually coming from and only using those particular values to evaluate this particular part of the limit.